Hello everyone, in this video I'll explain how to demonstrate sum of products, the SOP, and product of sum POS forms from a given truth table. So let's get started. Here's our truth table, and the ones in the output over here represent that it is true, and the zeros right here represent that the function is false. So step 1 over here is asking us to get the canonical sum of products, so the SOP. So to get that, we're gonna have to look at the table, and the canonical SOP are the rows where the output would equal 1. So all of these rows right here, I can just make a big circle on them right there. Those rows right there are gonna be the SOP. So to get them, basically, we can see that A's or X is equal to 0, Y is equal to 1, and Z equal to 0, meaning that the function would be A prime, B, C prime. So that this would, if I plug in 0, 1, and like 0, 1, 0, this would equal 1. So that's what I'm gonna do for the next 1, 2, 3, 4, 5, 6, 7, like 7, 6 of them, where I'm gonna write the functions so that I can use them. So this one is going to be a C prime, C, then A, B prime, C, A, B, C prime, then lastly A, B, and C. So all of these are equal to 1, equal to 1, equal to 1, basically. That's their output. So to get the CSOP, which is the canonical sum of products, so we are adding these products. So that's going to be Q equal, and by the way, I wrote ABC. That could be the same thing as X, Y, and Z. I'm just used to the X, Y, and Z. So over here, I'm going to write it with the X, Y, and Z form, okay? As an X prime, Y, Z prime, plus X prime, Y, Z, plus X, Y prime, Z prime, plus X, Y prime, Z, plus X, Y, Z prime, plus X, Y, Z. So once we have all of these right here, we want to identify patterns and group these together so that we can factor it out and make this into a SOP. That's the next step to simplify it. So to make it a SOP, we're gonna have to simplify and group it. So I'm gonna start with grouping maybe like 3 groups. Like let's say X prime Y Z prime plus X prime Y Z right here together. And then we're gonna plus, and the X Y prime Z prime plus X Y prime Z, then plus X Y Z prime plus X Y Z. So now that we have these 3 groups, I could probably factor out something out of them. So what is something that I can factor out here? I can see X prime Y on the first one that I can factor out. So I can make this into X prime Y Z prime plus Z. And then for the second one, I'm pretty sure there is another method here as well. What is it though? I can see that I have X Y prime as well. So if I factor X Y prime, I'm gonna be left with Z prime plus Z. And then the same thing right here. For the last one, I'm gonna factor out actually the X and Y and leave the Z prime plus Z. So all of these Z prime plus Z's is the idempotency add prop. Well, actually, it's the complementation add prop, so we can just say that that's equal to 1. It's 1. So the same thing for all of them. 1, X, Y, 1. And yeah, so we simplified this expression by a lot, actually, just by grouping them and switching them to 1. So after the step, I can probably simplify it a little bit more than that. I'm pretty sure I can. So Let's start to simplify more. See what can we get out from here. I can get out the x from that side. So I can say x prime y plus x times y prime plus y. And then make that y prime plus y into a 1. So equals x prime y plus x. And that is also another identity. And that's gonna equal to x plus y. And that's what our SOP simplified version would be. And that's our CSOP. So to find our CPOS, which is the canonical product of sums, we have to find the columns that output 0, which are these right here. So A, B, C, and A, B, C prime. That would equal 0. So again, I'm writing in A form over here. I don't even know why I'm doing that, but it is 7 a.m. right now. And for the CPOS, it's going to be Q equal, and I'm going to multiply these sums. So A plus B plus C, 0 plus 0 plus 0 is 0. That's our first value. And then our second value, I'm going to multiply the second sum, which is A plus B plus C prime. And that's it. We derived the canonical SOP and simplified the SOP and the canonical POS in this video just from the truth table. Understanding these forms was pretty important in logic circuits, and thanks for watching.